Today we're looking at special angle pairs. This is actually our last lesson for this unit. So let's get into it. There are two vocab words that we need to start out with. First is adjacent angles. Now think of the word adjacent. You've probably heard that before. Adjacent means next to. So you might have already thought about, well, two people might be adjacent to each other, or two objects must be adjacent to each other. With angles, to be adjacent, they need to share a common endpoint and a common side. So what this is going to look like, and you've actually seen diagrams like this already. We did a couple of these in the last video. So these would be, for example, here's one angle with an endpoint, two rays connected at the endpoint. And so an adjacent angle would be an angle that comes right off of that same endpoint, and they both have that middle side. So a couple examples that are, examples of that not being true. So we can't do this. So these are not adjacent angles. They don't have that common endpoint, so that is wrong. We also can't just have them kind of in the same vicinity of each other. Again, yes, on the paper I drew them kind of next to each other, but they don't share that common endpoint. They don't have that kind of touching side in the middle. So unfortunately, that also does not work. They have to have that middle side and the endpoint in common. Okay, the next pair of angles that we're going to do, and these are both involved in this first set of examples, is a linear pair. So a linear pair has two things to it. So they're adjacent angles and they're supplementary. So don't forget that means 180 degrees if you add them together. So a linear pair, again, kind of goes with the word. So if I have a line, a random point with an arrow, a ray coming off of it, these are actually two angles. So I have the one angle on the right-hand side that looks like he's an acute angle, and I have the other angle on the other side, looks like he's an obtuse angle. So these might be, for example, 60 degrees and 120 degrees, which add up to 180 degrees. And they share the side and angle, they share that ray. So they are also adjacent angles. So a non-example, I could have 120 degree angle here and a 60 degree angle here. These angles are still supplementary, but because they aren't adjacent, because they don't share a side and an endpoint, they are not a linear pair. And this actually kind of goes back to, you might be asked this, you've probably heard the question, a square, or the statement, a square is a rectangle, but a rectangle isn't a square. It's the same sort of thing on this. So a linear pair is supplementary. But if two angles are just supplementary, they don't have to be a linear pair because they don't have to be adjacent. So linear pair is always supplementary, but supplementary isn't always linear pair. Okay, let's look at a few examples. So example number one, we're looking at a diagram that has a whole bunch of angles in it. So this is asking us to name the adjacent angles to angle AFB. So we've got to find that angle first. So AFB. So we're looking at this right-hand angle, or excuse me, left-hand angle. Good morning. So that left-hand angle, what angles are adjacent to it? So again, adjacent means it has to share a common endpoint and side. So the first angle that I see that could qualify would be angle BFC. They both have the common vertex or the common endpoint of that shared side. Actually, I'm going to take that off because I make that looks like an E if I do that. So BFC is an adjacent angle. I could also do angle BFD, slightly larger version. What else could I use that kind of starts with a BF? I could do angle BFE. But if you think about it, we are using that common vertex, the F. So common vertex F. And you'll notice everything also has B in it, just like our original angle. Now, here's a non-example. So one that wouldn't work, angle AFC. It has that common point F, but it doesn't have a common side. It actually overlaps the angle that we're trying to use. We can't overlap it. We have to only share the adjacent or that side and the endpoint. So AFC is not an adjacent angle. Okay, number 2. Wait a second, has no diagram. So that's the first thing I want to do. We need to draw a diagram for this one. So we need to find the value of x if given that angle ABD and angle DBC are a linear pair. So the first thing I'm going to draw is, let's draw a linear pair. Okay, ABD and DBC, what letter do they have in common? They have letter B in common, so that's their common endpoint. What other letter do they also have in common? So they have the D. So that must be my ray, my side that's in the middle is BD. So then I can finish labeling my angle. So I have angle ABD, okay? So ABD. And I've got angle DBC, so DBC. Now I can label the rest of my information. So the measure of angle ABD is 4x plus 6. So 4x plus 6 for this angle. And then angle DBC is 11x minus 6. So again, if these are a linear pair, what property do they have besides being adjacent angles? They also add to 180. So I can actually use that map that I was using last time. Part plus part equals whole. Okay, so I just need to add together my parts. So I have part plus part is going to equal the whole. This is a linear pair, which is a supplementary pair as well, so they add to 180. So then I plug in 4x plus 6 plus 11x minus 6. And it wouldn't necessarily be a bad thing to put parentheses around these. It will help me organize. And then I can double check, hey, do I need to do anything different with my signs? So 4x plus 6, there's no negative sign out front, so I can just rewrite that as a plain 4x plus 6. 11x minus 6 has the plus in front of it, so that means I do not need to distribute any negative through there, and I'm just working with plus 11x minus 6 equals 180. Then I combine my like terms. I have a 4x and an 11x, so that gives me a 15x. And then I have a plus 6 and a minus 6. Wait a second. Plus 6 minus 6, they cancel each other out. They come out to a 0. So I don't really need to write a plus 0. I'm just going to keep with 15x equals 180. So then to get the x by itself, I need to divide both sides by 15. So x equals 12. I'm going to go back and make sure that I read my question completely. Am I answering everything that they're asking me? So find the value of x if given that. And then the rest of it is info. I solved for x. I'm done. Okay, wait a second. I just asked you the next two questions. Are all linear pairs supplementary angles? So think about your definition. If I have a linear pair, two angles drawn adjacent to each other, they have that common side, but they make this nice straight line. What do these two angles together have to add up to? They have to add up to 180. So this one is yes. It's part of the definition that they have to be supplementary angles. But the other one, we're reversing that. Think about your logic. What is it when we reverse our statements or reverse our ideas? Now that's our converse. Converse is switch, inverse is not. So the converse are all supplementary angles, linear pairs. So it's asking you basically, is this a true or false statement? So when we did this before, well, if we think it's true, okay, cool, it's true. But do you have a counterexample? Well, counterexample could be, could you think of supplementary angles that don't make a linear pair? What about a 100-degree angle and an 80-degree angle. If I draw them like this, do they make a linear pair? Well, no, they're not adjacent. So I just found a counterexample, so no, they don't need to be adjacent. Alrighty. So let's look at our next type of pair. Here we go. Oops, I don't have it set to scroll that way. Let's see here. Vertical scrolling is on. So our next pair is called vertical angles. Now this is a little bit misleading. Vertical, you're used to thinking of a vertical line, and that actually might help you a little bit with understanding what's going on. So vertical angles are formed by two intersecting lines that are directly opposite from each other. Okay, so I'm going to draw that. So formed by two intersecting lines. So here's one line, and here's two lines. They intersect at this point. So how am I going to name these points or these angles? I don't have any letters in my diagram. So you could name letters with or name angles with letters like we've done so far. But one thing that you might start seeing is actually having the angles numbered instead of letters. And when you have a lot of angles in your diagram, using numbers to identify them actually saves you a lot of time. So I'm going to call these angles 1, 2, 3, and 4. So again, how did we mark congruent angles when we talked about that before? So our congruent angles, we would use an arc on the matching ones. So vertical angles are directly opposite from each other. So these are angle 1 and angle 3. Wait a second. Does it look like I could fold that diagram over and match up those angles? Huh. So we actually have to add something to our definition, which is vertical angles are always congruent. So I'm going to mark angle 1 and 3 directly opposite from each other. Again, I could fold them over each other and they'd overlap perfectly. Those guys are congruent. Is there another pair of angles that's straight across from each other that look like they could be congruent, like I could fold the diagram over and match it up? Well, angles 4 and 2 have the same thing happening. So I can mark those as congruent. Again, I'm going to use a different number of arcs. This is why we use those different numbers. You can see, hey, they both have double arcs on them, so those must be the matching angles. So one of the ways that we could write this is, let's say that these angles are congruent. So we haven't had to write this yet. I'm going to say angle 1 is congruent to angle 3. So notice the symbol I used, it looks like an equal sign with a weird little tilde on top. And that's your symbol for congruent. We don't want to use equal because I'm not really talking about measures right now. I am just talking about those two angles match up with each other. I can also say that angle 2 is congruent to angle 4. Again, perfectly equal measures, but we don't have measures that we're working with. We're just dealing with the actual objects right now. Okay, so you want to be careful that you have those two intersecting lines when you're identifying your vertical angles. So in example 5, identify each pair of angles as adjacent, vertical, and or a linear pair. So for each one, I'm going to color code to kind of help me out. So angle 1 and angle 2. So angle 1 and angle 2, they're sitting right next to each other. They share a side, so they have to be adjacent. Okay, let me change my color. So angle 1 and angle 6. So angle 1 and angle 6, what can we call those? Well, those are adjacent too. They have that shared side or that shared ray QP. So they're adjacent. But could I call them anything else? Well, they have that straight line VR, And because that's a nice straight line, and I have my adjacent angles, my angles 1 and 6 look like they could add up to 180 degrees. So these guys are also supplementary. But that means if they're adjacent and supplementary, what can we really call them? So I'm going to change my answer to linear pair. Now, adjacent and supplementary are correct, but they are most specifically, because they have both of those, a linear pair. Okay, let's look at our next one. Angle 1 and angle 5. Well, my diagram is getting kind of messy. I think I can get one more in before I erase it. Angle 1 is this one. Angle 5. Actually, no, I'm going to go ahead and erase my diagram. Let's start fresh on this. So angle 1 and angle 5. Well, when I trace over my sides, what does it look like I also have? If I start on the bottom side with angle 1 and I just keep going, it goes to my side that I already traced for angle 5. And same thing, the top side of angle 1, trace it back, goes back to the side of angle 5. So those guys are a vertical pair. They are vertical angles, or a vertical pair of angles. Okay, last one, angle 3 and angle 2. So angle 3 and angle 2. What do you think? Yep. That's another adjacent pair. Okay, example 6. We are told that line LM and line NO intersect at point P. So two lines intersecting, I'm thinking this probably makes vertical angles. We need to find the value of X. Now look at where we have our info labeled. So we have this expression 7 plus 13x on the left-hand side for angle LPN. So I'm going to go ahead and highlight him. And then my other expression, negative 20 plus 16x, that's sitting right in the middle of angle OPM. Hey, what are those in the right spot for? They make vertical angles. So vertical angles are always going to be congruent to each other. So what's another word for congruent? So congruent objects have equal measures. So if you see that something is congruent to another object and you have an expression written down, you can just set those equal. So I can actually say that 7 plus 13x equals negative 20 plus 16x. And you'll notice I didn't really bother with my parentheses. It wouldn't be a bad thing, but I knew that I was going to set those equal, so I wasn't going to have to worry about distributing any negative signs. So we just need to solve out for x, because there we go. Find the value of x. That's the only thing they're asking us to do in this problem. So here we go. We need to start moving things around. And you could have a couple different choices on here, but my suggestion is going to be, let's move the 13x. The reason I'm choosing to do that is between my 13x and my 16x, my larger coefficient, 16, I'm going to move things over there so I don't have any negative values that I'm working with. So I'm going to subtract 13x from both sides. Again, this isn't the only way to do the problem. If you want to try this on your own using a different method, just make sure you get the same answer as I do. So that cancels the 13x on the left-hand side, leaving us just with 7. We have a negative 20, and we have positive 16x minus 13x. We have a positive 3x left. So then let's move the negative 20. So we would want to add to both sides. So plus 20, cancels out our 20s. We have a 27 on the left, a 3x on the right. To solve out for x, we need to divide both sides by 3, and 27 divided by 3 is 9. So x equals 9. Again, if you tried another method, as long as you got out that x equals 9, that is a valid algebraic way to attack the problem. Okay, one more problem, number 7. Okay, again, I gave you the info, but I didn't label it. So we don't know what attack method to use yet. It could be vertical angles, it could be supplementary angles, it could be linear pair. I don't know until I organize my information. So this one asks us, find the measure of angle SOR if angle SOP is 5x, so SOP is the angle on the left, and angle ROQ, again, ROQ, trace my side, so I'm looking at the right-hand angle, 4x plus 10. So looking at where these are, they look like vertical angles. So we can do the same thing as example 6. They're vertical angles, they're going to be congruent, their measures will be equal. So I can say that 5x equals 4x plus 10. I can solve this in one step. All we need to do is subtract the 4x, and then x equals 10. But is that what they were asking for? So here's the kicker. The first sentence said, find the measure of SRO. Well, angle SRO, wait a second, SR, or SOR rather. Wait a second, that's the top angle. I don't even have that angle labeled. But what do I know about another pair of angles? Let's see here. If I paired my blue angle, the top angle, if I paired that with the 5x, what would those two angles add up to? They would add up to 180 degrees. So if I knew the measure of 5x, which I can find by taking x and plugging it back in, I'd be able to figure that out. So, well, that's not too bad. Well, 5x, plug 10 in for x, that means that measure there is going to be 50 degrees. So I have kind of a secondary problem I need to do now. So now I need to know part plus part equals whole. So I have angle SRO. I don't have anything labeling it except for letters. I don't want to use a number to confuse it with the algebra. So I'm going to call that guy y. I'm just going to give him a new variable. So I know if part plus part equals whole, I know then that 50 plus y, if I add those together and they make that nice straight line going POR, they have to add up to 180 degrees. So this kind of combines two different kinds, linear pair and vertical angles, all in the same problem. So if I'm solving out for y, that missing top angle, all I have to do is subtract 50 from both sides. So that means y equals 130 degrees. So our formal answer, the measure of angle SOR, is equal to 130 degrees. So again, always be careful. You'll notice I read that problem 3 times. Don't just read a problem once. Read it through to get the lay of the land. Read it through again to make sure you have your diagram labeled and you understand the information they're given or giving you. Then after you solve, read it again to make sure you actually answered the question they were asking. So be careful. This is one of those instances I had to plug it back in to figure out my final answer. Okay, let me know if you have questions.